Hello everyone. In the basics of signals and system, we have already discussed about the different basic elementary signals. We have also discussed about the different operations on a discrete time signal. Now in this particular session, we are going to discuss one more very important topic of signals and system, and that is classifications of discrete time signals depending on their characteristics. So this is going to be a very interesting session and important session. This particular session is also very important for the semester examination point of view as well as the gate examination point of view. So let's start. Basically, a discrete time signals are classified into the following types depending on their characteristics. The first category is deterministic and non-deterministic signals. Second one is causal and non-causal signals. In causal and non-causal signals, we will also discuss about anti-causal signals. I have not mentioned anti-causal here, but we are going to discuss about anti-causal signals also. Symmetric, which is also called as even signal, and antisymmetric, which is also called as odd signals. Next, we will discuss about periodic and aperiodic signal, which is also called as non-periodic signals. After that, we will discuss about energy and power signal, which is also a very important topic. So let us first discuss about deterministic and non-deterministic signals. Any discrete time signal can be called as deterministic if it can be completely specified by some mathematical equations. Otherwise, we will call it as non-deterministic. So you can see the definition of non-deterministic also. A discrete time signal is said to be non-deterministic if it cannot be specified by any mathematical equations. We will understand this particular sentence in more detail. Now the second point is, the signal can be determined or analyzed at every instant of time, whereas a non-deterministic signal cannot be determined or analyzed at any instant of time. So basically, the examples of deterministic signals are step signals, exponential signal, ramp signal, sinusoidal signal, and all other signals which are specified by the mathematical equations. As you can see, one functional and graphical representation of a ramp signal is given over here. The ramp signal, unit ramp signal R of n is always equal to n for n greater than equal to 0 and is equal to 0 for n less than 0. Depending on this particular functional information, we can plot the graph for unit ramp signal. As you can see, at 0 it is 0, at 1 it is 1, at 2 it is 2, at 3 it is 3, and so on. So basically, at any instant of time, if you want to find out the value or amplitude, then you can easily find out by this mathematical equation or this graph. Let I want to find out the amplitude at 10 seconds. Then I can say that at 10 seconds, the amplitude will also be 10. So in this way, any deterministic signal can be specified by any mathematical equations. So in this way, we can say that at any instant of time, we can determine the amplitude value of the signal. Now in the same way, the best example of non-deterministic signal is the noise signal from various sources. As you can see here in this particular graph, you cannot determine the amplitude at any instant of time. You choose any time over here. Let I am choosing this particular time. What will be the amplitude? I cannot determine the amplitude just because I don't have any mathematical equation depending on which I can calculate the amplitude value. That is why a noise signal will be the best example of a non-deterministic signal. So this is all about deterministic and non-deterministic signal. So basically, from the deterministic and non-deterministic portion, you will only get 2 marks question in semester examination. And very rarely you get a question in the gate examination from the deterministic and non-deterministic signal.